Starting right now. So,
So,
good evening once again. Today we are tackling data structures, the topic being linked lists. My name is Mary Mutuku. I'll be taking you through linked lists today. So, what we are going to cover on today's topics: number one, what are linked lists? Number two, key component, key components of a linked list. Number three, the advantages and disadvantages of linked lists. Number four, types of linked lists. And then the basic operations on a linked list. And then finally, number six, we get to wrap up. This will include questions and more topics after that regarding linked lists, of course. So, what are linked lists? Linked lists are linear data structures in computer science that are used to organize and store data in a form of a chain. The structure of a linked list is such that each piece of data has a connection to the next one, and sometimes the previous data as well. This is in the case of double linked list. Yeah. Another type of linear data structures is an array. In arrays, data is stored in a contiguous block of memory, which is allocated to store elements. For example, like in the image below, this is a memory that has been allocated to store an array, and you'll find that at position 1 we have number 2, at position 0 we have number 2, that's index 0, at index 1 we have number 4, at index 2 we have number 10, and so forth. So data in this array, you'll find that two the data in 2, 4, they're in a contiguous block of memory. So accessing them, like if you want to access an array at position, the array element, if you want to access the data value at an array at position 0, you'll reference to that array and then 0, and then you'll get the data value, which is number 2. So when it comes to linked lists, unlike arrays which use contiguous memory allocations to store elements, linked lists are a chain of nodes where each node contains data and are linked to the next node sequence. And like I said earlier, sometimes in the previous data as well, in cases of double linked lists. So in linked lists, these nodes, they are scattered in memory and are linked by pointers, which form a chain-like sequence. So in this case and scenario, we'll have a linked list. A linked list will have a head. The head, in in this example, we are using a single linked list. It will have a head and a tail. The tail being the last element in the single linked list. And then this node, now this particular part that I'm pointing at is a node. It will contain data and a reference to the next node value for B. And these nodes, they're scattered in memory. So you'll find that the next, it's like a pointer that points to the other node, the next node, that is. So when it comes to key components of a linked list, I think I had touched on this earlier in the previous slide. So we have a node, which is the basic building block of a linked list. For singly linked lists, a node has two fields, that is data to store the value and a reference, which is usually a pointer to the next node. A doubly linked list has three fields where there is an additional reference to the previous node. So if in this picture here, if this was a doubly linked list, we'll have next to, okay, before the data thingy here, we'll have a previous field. That previous field is a reference maybe to the previous node. In this case, like at this point, it will point to null since there is no previous node. And if we were to use like the second part here, we find that there is previous pointing to this node here, and then next the data